Okay, so our goal is to find this integral. Now, before you do anything, let's just talk about what we could do. So we could use some sort of trigonometric identity. We could use integration by parts, but we're not going to do that because that will go on forever, because we both have sine and cosine here. And what type of trig identities? You see that there's a sine divided by cosine, so you're like, oh, maybe I could do a tangent. And I'll tell you, maybe don't do tangent, because like tangent integrals aren't really nice, right? So why don't we just maybe use our favorite identity, which is what? Sine squared x plus cosine squared x equals 1. Why don't we use that? But then we don't have like a cosine squared, so we just have a sine squared in here somewhere, right? We have a sine times a sine squared. So let's rewrite this identity as something a little bit nicer, and we could rewrite it as 1 minus cosine squared x is equal to sine squared x. Right? So that's true, right? And that's nice. Now we can rewrite our integral as sine x 1 minus cosine squared x divided by cosine x. Okay. And what we can do is we can possibly do a little bit of a trick here, right? And what's that trick? Is we could say, well, before I do this, let's let u equal cosine. Just cosine. Let's just let it equal cosine. So that way we can get rid of both the cosines. So if we let u equal cosine, then we know that du is equal to negative sine x dx. In other words, we know that dx is equal to what? Du divided by negative sine x. Okay, so if we use all those facts, what we can do is we can write our integral, and then we'll have 1 minus u squared divided by u, and then we remember we had a sine x here, but then our dx is now this thing, so we have a du divided by negative sine x. So you can see the sine x's can cancel, but we have a negative 1. So what we get here is we get what? So keep in mind that negative 1 doesn't go away. So what I'm going to do is just put it into this, right? I'm going to put it into that, factor in the negative 1. I'm going to get u squared minus 1 divided by u du. So that's my new integral, and that's a lot nicer. That's really nice, isn't it? Because we can break this down into just what? U squared divided by u du minus 1 over u du. And then you can see here that, oh my god, look at that. That's just the integral from u du minus, and we know this integral by heart now, right? Because we've done it so many times, which is negative ln u. Alright, so now all we have to do left is compute this integral, and we know that one is really one of our favorite integrals. It's just going to be u squared divided by 2. That's it. So then now our integral, right? This integral over here is simply just equal to what? U squared divided by 2 minus ln u. But remember, we're given sine x and cosine x. This like means nothing to us, really, until we put a sine x and a cosine x. And by the way, don't forget a plus c. So now we're going to insert our substitution back in here. So we're going to have cosine squared x divided by 2 minus ln cosine x. And what you can see is that maybe we can write this as here. So the way logarithms work, if you have a negative on the outside, you can put it in here, and then it's going to become a negative power inside in here. So then we have cosine squared x divided by 2 plus ln secant x plus c. There you go. So this is like, I think, like, in my opinion, the nicest answer you can get. I like it. There you go.